Hey guys, this is Cam from EasyA. This is going to be the second video on circle theorems. So let's get started.
Let's say we have a triangle here where one side is the diameter of the circle. We can prove that the angle here on the circumference is always a right angle. First, split up the triangle by drawing in a radius here. This creates two isosceles triangles. So let's mark on the angles which are equal here. These are at the base of the isosceles triangles. Now let's consider the whole triangle we were thinking about earlier. The angles in this triangle will add up to 180 degrees. Working this through shows that a plus b is always equal to 90 degrees. Now let's prove that angles in the same segment are always equal. First, let's draw two angles in the same segment, and then we'll draw the angle in the centre of the triangle. Let's label these A, B and C. Because the angle in the centre is always twice the angle of the circumference, 2A equals C. But also 2B equals C. So setting these equal to each other shows that A is equal to B always. Now let's draw a cyclic quadrilateral, which is a quadrilateral where all the points lie on the circumference of the circle. Angles opposite to each other in a cyclic quadrilateral always add up to 180 degrees, so let's prove this. First, mark on the pair of angles x and y. Then draw two radii here. Because the angle in the centre of the circle is twice the angle of the circumference, we can mark on the angles 2x and 2y. Now let's sum up the angles around the centre, as they should add to 360 degrees. Adding them up shows that x plus y is always equal to 180 degrees. Now let's look at the tangent to a circle. This is always perpendicular to the radius, as there's only one way we can draw it, so it touches the circle once. Let's draw two tangents here which meet at a point. We want to prove that the length of these tangents must always be the same, so we're proving that AI is equal to BI. First, draw the line OI to create two right-angled triangles. These triangles both have the same hypotenuse OI, and AO and BO are both radii of the circle, so they have the same length. As they both have a right angle, they're congruent due to the RHS rule, so the tangents are equal in length. Now, let's prove that the perpendicular to a chord always bisects it. This is the shortest distance from the centre of the circle to a chord. To prove this, first draw on radii OA and OB. Then we can mark the point M as the midpoint of AB. We want to show that AM is equal to BM to show that the perpendicular bisects the chord. These triangles are both congruent due to the RHS rule, so the chord is always bisected by the perpendicular. Finally, let's look at the alternate segment theorem, which shows that the marked angles are equal. Let's first prove this is true for angle A. Draw on the radii MO and FO. MO is at a right angle to the tangent, so we can write on the angle 90 minus A. The triangle is isosceles, so the angle OFM is also 90 minus A. Again, the angles in this triangle add up to 180 degrees. This shows that D is equal to 2A, but D is also equal to 2E, as it's the angle in the centre and E is the angle on the circumference. So, setting these equal shows that A is equal to E, and we've proved the theorem.
Thank you for watching this EasyA Maths recap video. Check out our YouTube channel for more maths recaps, or get the EasyA app on the Apple and Android app stores to get unlimited on-demand maths tutoring right from your smartphone.